The universe is a weird world, full of mysteries and unusual possibilities that, no matter how evolved our society and science become, may remain total unknowns forever, no matter how advanced our civilization and science get. So here are some strange universe-related ideas that we may never comprehend. Number 10. We may never know what gravity is. One of science's greatest issues is the nature of gravity. We don't know much about something with which we are frequently in contact. Newton attempted to address the issue, but only provided a generic way of defining how it acts, not what it is. Even yet, Newton was only marginally wrong. Einstein took it a step further, but he spent his final decades attempting to find out what gravity is, to no avail. Scientists now understand how gravity acts in the context of space-time and can forecast it extremely well. But the force itself remains unexplained. The presence of an elementary particle known as the graviton, which mediates the force of gravity, is one theory. The problem is that gravitons have never been discovered, and their existence is doubtful. Einstein viewed gravity as a distortion in space-time, or an intrinsic acceleration towards big things in another way. The problem is that this is an incomplete perspective that only defines how gravity acts rather than what it is. Perhaps the most peculiar element of gravity is that, as a force of nature, it is terribly, incredibly weak. Take a look at you. To keep you on the ground, you need the full mass of the planet to produce adequate gravity. Yet, when we launch space missions, we frequently defy gravity. Why it's so weak adds to the enigma, and recent research on whether gravity is weak because it's largely seeping into other dimensions came back negative. So gravity remains a big mystery, and while we may one day fully comprehend its nature, there's also a risk that we won't. Number 9. Is the universe infinite? We are in a bubble within the cosmos. The observable universe is what we call it, and beyond it is more of the world that we can't see. This is due to the speed of light. Objects beyond a certain distance cannot be observed since the cosmos hasn't been around long enough for their light to reach us. One unanswered question in cosmology is how much more cosmos exists beyond what we can perceive. Some believe it is small, while others believe it is significant. But there's another possibility. It's endless, which opens up some extremely odd possibilities. In an endless world, it's possible that if you go far enough, you'll come across a slightly different Earth with another you living on it. You could come upon another later. Again, slightly different, and so on, eventually leading to a sort of tangible, real, parallel reality, all existing within the same world. Given that humans will never be able to view the entire universe owing to its expansion, this question may never be answered. The 8th experiment is the double-slit experiment. This weird characteristic of our cosmos is one of those things that, when written mathematically, makes sense yet looks nonsensical to a person. However, after hundreds of repetitions, the double-slit experiment consistently produces the same result as both waves and particles. The concept is to fire particles such as electrons into a baffle with 2 slits cut into it. A wall exists behind the baffle. As the electrons travel through the slits, an interference pattern appears on the wall, showing that the particle is acting like a wave, similar to an ocean wave passing beneath a pier. When you monitor the particles with detectors on the other side of the baffle, the interference pattern on the wall fades and transforms into 2 slits, suggesting that the particle is operating as a particle rather than a wave. To put it succinctly, the act of simply seeing it alters the outcome of the experiment. We may never completely comprehend why this is the case. Number 7. Will the universe perish someday? What will happen to the cosmos at the end is a big mystery in cosmology. In one interpretation, it will simply continue indefinitely until all stars burn out, black holes evaporate, iron stars emerge, and everything goes dark at some moment, but it continues indefinitely. This offers up highly strange possibilities of chance and unlimited time, such as the Boltzmann brane, in which random fluctuations, if given enough time, will enable some type of awareness to come out of nowhere in the dead cosmos. However, it is possible that the cosmos will end sometime. This argument has not been addressed within cosmology, and many probable endings of the universe have been presented, but two stand out. The first question is whether the proton can decay. This is uncertain, but if they do decay, the cosmos would basically cease, since all matter in the universe would just disintegrate. Another theory is that the cosmos is unstable in the sense that it does not exist in its genuine vacuum condition. If anything happened within the cosmos that forced some of it into the genuine vacuum, the consequences would be terrible. The entire cosmos would be torn apart as it expanded at the speed of light toward the actual vacuum. This might have a significant impact on how the universe operates, such as how gravity works or how matter is constructed. At the very least, the worlds we knew would cease to exist, and we would very certainly perish. Fortunately, the time periods for this to occur are most likely much longer than our species can live in the cosmos. Number 6. What caused the Big Bang? In general, the earlier in the Big Bang process you go, the less modern science understands. Take note of the Planck epoch. When applied to the very early seconds of the Big Bang, scientists' theories of the cosmos, notably Einstein's general relativity, no longer predict what transpired. What can be done is some educated guesswork based on data from the Big Bang, such as cosmic microwave background radiation, and there are various hypotheses that may someday prove to explain what actually happened. String theory and its derivatives suggest that the cosmos is suspended on a type of membrane. The huge boom was caused by the collision of this membrane with another membrane. Others believe that the whole affair was set off by quantum disturbances, or that the world is one of many in a multiverse where universes bud off of other realities like flowers on a tree. There have also been ideas that the cosmos is the other side of a black hole, known as a white hole, when matter departs the black hole. Whatever the case may be, because we have no method of observing what happened during the Planck epoch, we may never truly comprehend what occurred. Number 5. Spooky action at a distance. We commonly think of the cosmos as a vast expanse of space. Any two items can be separated by virtually incomprehensible distances, so far apart that they can never even see each other. However, in the quantum mechanical world, the absolute idea of separation is not necessarily fixed in stone. In reality, distant particles may be linked to one another at huge distances by a quantum physics phenomenon